Hey everybody, this is Larry. This is day 18th of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. We move nth node from the end of the list. Okay. Given head of a linked list, we move the nth node from the end of the list and then return its head. Could you do it in one pass? Wow. I always generally hate these problems. But anyway, I do try to solve these live. So if it's a little bit slow, fast forward or watch N2X or whatever you need to do. Okay. So can I do that in one pass? What is n? Do they give you? Oh, well, I mean they give you nth node, but I mean like what is the size of the list? I feel like there's always like with these problems, there's always some like weird trick with respect to like using 2 pointers in a weird way, but let's see, right? Like using the 2 fast pointers or something like that to get the middle of the list. But then now we want to get the nth. How do we get the nth from the back of the list? I don't know that I know how to do this in one pass. I mean, in 2 passes is very trivial. You just kind of, you know, one pass to get the length of the list, and then the second pass to remove the nth node. So that's, and that's just, doing the math. But I'm trying to think about the one pass. Is that the follow-up? Maybe that's the follow-up. But let me try to do the follow-up for a little bit, and if I can't get it, then maybe I'll just ignore it. but what does it mean by the nth node, right? That means, let's say we're trying to get the last node. How do we know that is last node? Well, that part should be pretty straightforward because that's just whatever. How about the second to last node? I'm always very weak at these because they don't really come up in real life or in competitive programming. I guess these things don't really matter. It's just I mean, I don't know. I was just looking at examples, but yeah, I knew what the problem was asking, so I don't think there's any ambiguity other than maybe off by 1, but that could be fixed. Oh, how do I get it? Like this. Does it count as one pass? I mean, does it count as one pass? You have 2 pointers? I don't know. Because you could have 2 pointers and no, I mean, I guess that's just like almost cheating, to be honest. I was thinking about some ways around that one. What else is there? Yeah, I don't know. I don't think I know how to do this one. Let me look at the hint. That's what I was thinking, but how do you? Oh, actually, yeah, okay. I see. Okay, that's smart. That's a very big hint. I always forget it. I don't know. These things don't really come up that much, and they're really silly. So I'm not very good at them. So maybe I need the hint. But the idea now is that okay. Let me actually put up paint right now. The hint really did give it away, I guess. Let me put up paint. So basically, the idea for this one then it is that you have some linked list. I have to draw it. You have something like this that looks like this, right? So then now you have one pointer that's, let's say your x from the end. So then let's say n is 2. So then you basically want to start it so that there's 2 pointers away, and then you kind of move it in lockstep, right? And then when you move them together, the second pointer will the slower pointer will be at the very end, because you know that it's 2 away, because you know that this is the invariant of this thing, is that there's 2 away between these two. So yeah, so I mean that's pretty straightforward actually. Like I said, I'm really bad at this clearly, so I needed a hint to cheat. So yeah, yeah. But these things are always a little bit weird, because I always feel like if you're using 2 pointers, is it really 2 passes? Or I mean, is it really 1 pass? I guess so. But for a linked list, because the thing is that if you're using arrays or something like that, the 1 pass 2 pass thing, it comes from the pass where you know the memory is stored in, you know, there's localization. Is that the right word? But basically, the memory is stored in a you know, in similar memory locations, and because of that, it's easier to cache, and it's easier to use lower level cache. And in theory, at least back in the days, this would give you a lot of performance to do in 1 pass instead of 2 passes, right? Because then everything is in memory, so you don't jump around all the time, or like, you know, the second pass. But the thing with linked lists is that the memory is already like all over the place, and also if you have 2 pointers, the memories are already like, you have to load different parts of the memories and of different things depending on what n is or whatever, right? So as a result, you don't actually get that much benefit from a second pass, or sorry, with the quote unquote 1 pass, when they really mean just 1 for loop, because that second pass is not really that beneficial to performance or something, right? So yeah, yeah, that's mostly my complaint. So yeah, so for these, I usually write something like a new head is equal to list node of -1 and head. So this is just a new head that points on to the head, so that if we need to remove the head, this makes things easier, as I said, to do that. And then yeah, we have a fast pointer is equal to n head, and a slow pointer, that's okay. And also, like, for now, does this count as you know, 2 pass if I do this, where, you know, it's a little bit awkward though. So yeah, and then now we can do like while fast is not none, fast is equal to fast.next, slow is equal to slow.next, and then now we remove slow or slow.next, maybe, I don't know. Yeah. Let's just print it out real quick, just to make sure that we're off by 1. It's not that much of a difference, of course. So we want to remove 4, right? So that means that we're removing the right thing. So then now we can just do slow.next is equal to slow.next.next. And this should not be, because fast is .next is not none, but maybe there's some edge cases, I don't know. Also, let me yeah, like I was removing the next instead of the so yeah, so maybe this is n-1 then. No, n+1, sorry, whoops. Yep. I mean, this looks good. I just want to make sure that I am doing the right thing, and also removing the right node. And I want to actually do this, but remove n is equal to 2. Testing my edge cases. Okay, so that looks good. So let's give it a submit. It's a little bit awkward, right? Because do you count this as a second pass? I guess it's not a pass through the entire list, but it's just like at a certain point, I don't know. But anyway, so this is linear time, constant space because we just have a couple of pointers, and linear time because we go through the array, you know, twice, or like, you know, fast and slow. So yeah, That's all I have for this problem. It's a little bit brain teaser-y, to be honest, if you ask me. Like I said, for reasons that I mentioned, it doesn't really come up that often. And in competitive, it's really hard for them to test you for stuff like this. So yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and yeah, stay good. Take care of yourself. Take care of your friends and family, and yeah, to good mental health. I'll see you later. Bye bye.